to start off with, we have this map. And it's an area in New Zealand. I'm going to do my best to pronounce the names correctly because most of them are in Maori, but I've just moved here and I'm getting used to it. So I'm sorry if I mispronounce things, I'm trying my best. So we've been given this map and the task says the following. The government is considering creating a cycle network around Waikato that will enable cyclists to travel on dedicated cycle paths connected to the following towns: Hamilton, Matamata, Pirongia, Tiawatumutu, Cambridge, Tirau, Tikuti, Tokoroa and Tapau. They have asked that the local cycling groups state what their priorities would be. The Tapau Club would like the cycle network to provide the shortest route between Hamilton and Tapau. So straight away we can look at this and think, well, what are they actually asking for? So they're looking for the shortest route between two places. So this is actually going to be a shortest route task. I'll get a different colour. So we can find the shortest route in several ways. We can use a tree diagram. We can use a inspection, which means we look at it. We can use trial and error, and also we can do the shortest arc from the currently activated node. And I'll go through each of those. Okay, next job. Then it says the Hamilton Club would like a network of paths that connect all towns, with the resulting network costing as little as possible. So here, we need to connect all of the towns, but we don't have to use every single arc or every single road between each town, and it must cost as little as possible. So this, if it's connecting all towns, but we don't need to use every single arc or road, this would be a minimum spanning tree. Now, for this, we can use either crucibles or prims. And you have a choice, depending which one you like the best. And I'll show you how to do crucibles on the actual graph or map. And I'll show you how to do prims both on the graph and also from a table. Then it says the Tirau group would like a network of paths that connect all the towns, with the resulting network being one of the greatest scenic value. So again, we want a network of paths that connect all towns, but it doesn't state that we need to traverse or go over every single road. So that means, again, it's a spanning tree, but this time it's a maximum one because we want the greatest scenic value. So that's going to be a maximum spanning tree. So already we're using 3 different tasks. And again, for this, you could use crucible or prims, but you just have to adapt it for the maximum. And then it says, find a different colour, a long green pen, there we are. The Tokoroa Club has no views, but have asked if all the possible paths were made, whether they would be able to cycle along all of the paths to visit all of the towns without repeating a path, starting and finish at Tokoroa. So if you're travelling every single path and you don't want to repeat it, but you can visit towns as many times as you like, this would be checking for traversability. Now, traversability is looking at odd and even nodes. And we'll explain that at the same time. Okay, so now we've analysed the information they've given us and we can check to see what our actual task is. So it says here, Use the route information, distances, costs and scenic values in Resource 1 to prepare a written cycleway route recommendation to the government by finding the networks that meet the requirements of Tamilton, Tapau and Tirau. Create a network that satisfies the priorities of the 3 clubs, demonstrating how your network meets the requirements. So it looks like we're going to have to create all 3, and then we're going to have to combine them in some logical way. And we'll need to assess it to see if it works. And obviously make some conclusions. And then it says we must address the question from the Tokoroa Club. So clearly it has to be traversable. The description of your networks, the quality of your justifications, and how well you link your findings to the context will determine the overall grade. Clearly communicate the different parts of your solution using appropriate mathematical statements. So it's not just, by the looks of it, showing that you can analyse and you can work out the different methods and use them appropriately. It's actually showing, can you then analyse them, compare them, contrast them, and tailor them and draw suitable conclusions from it. So now that we generally have an idea about the task, let's just check where we want to be. So to get an achievement, and this is worth 2 credits, we have to apply network methods in solving problems. So I'm guessing you're going to have to use, or I say I'm guessing, I'm not. You have to use some of the methods that we've discussed and use them accurately and draw some conclusions about them. Then apply network methods using relational thinking and in solving problems. So this one, you would use the information that you've gleaned, the networks that you've designed, the routes you've designed, and then analyse them against each other to draw some simple conclusions. Then for an achievement with excellence, which is what we're aiming for, apply network methods using extended abstract thinking in problem solving. So from this, I'm assuming, because I haven't completed the full task yet, or I'm just starting out, that I'm going to have to address all of these situations and then combine them in some logical way, maybe by adapting them slightly, and then draw conclusions and really clearly explain my decision in my report. So that's our start. The first thing to do is actually look at resource 1 and see, well, what have they actually given us? And in resource 1, what they've done is they've given us the map of the area. They've given us a smaller map of the area so we can make sure we found all the places. And then they've given us 3 grids. And in this grid, the first one shows the distance between each area in kilometres. So for instance here, we have Matamata and Cambridge because they both meet in this region. So 41 is the distance between those 2. Whereas here, the cost of the cycleways will depend on the terrain and infrastructure. This is describing costs, so it will be the distance in towns in terms of how much it would cost in $100,000. So here, for instance, Matamata and Tirau would have $630,000 to create a cycle path between them. The next says the scenic value of cycleways between the towns in the region on a scale of 1 to 10, 10 being the highest. So looking at this, Awamutu and Tikuti is the most beautiful place to cycle, and Tirau to Tokoroa is the least. So I think this map's pretty hard to understand, so I'm going to print it out much larger and in colour, and I'm going to make annotations on it from that point.